Aloha. So I'm here with Dr. Mike Meltzer today, who works for CTAR at University of Hawaii at Manoa, and he runs a program called the UH Coconut Rhinoceros Beetle Response Team. And that program is looking for a biocontrol, a way to control CRB and keep the populations down, which is super exciting. So Mike, can you tell us a little bit about how it is you go and you find diseases that might kill off some of these beetles?
Yeah, no, that's a great question. Basically, we're doing what other people have already done. This work has been done since the 1970s, where people have been releasing, they found diseased CRB, mostly in Southeast Asia. And they've used that, they identified that there was a virus causing the disease. And so they purposely went around and spread this virus wherever CRB shows up, including other Pacific islands, places in Southeast Asia, and it's probably one of the most important management tools for CRB in its native and its expanded range. So we're basically just following the footsteps of what a lot of other people have already done. The difference for us is that, we have to get a lot of permitting to bring that virus into Hawaii. There's this thing called the Nagoya Protocol that requires us to have collaboration with these other countries in order to use their, biological resources. And so that's some of the things that we have to first achieve before we can actually go out and do widespread collections. And we're interested not only in the virus that other people have found, but we think there's probably other good biocontrol agents for CRB out there, particularly pathogens. And that's basically going to involve just traveling to these countries, looking for sick insects, maybe doing some field work to try and identify what type of a disease or pathogen they have, and then bring those insects and pathogen agents back to Hawaii for testing.
Fantastic. Now I understand you got permits back a few months ago to start this research. What do you actually do once you have those viruses in your lab here in Hawaii?
Yeah, so our first collection happened our permits were come in 2025. We did our first field trip to Palau, working closely with our colleagues at Palau Community College, and we collected about 36 diseased insects from across the country. We brought those back and immediately started doing bioassay work just to maintain that live virus in our laboratory. And that basically involved injecting larvae with somewhat purified forms of the virus so that they could get sick from it. We wanted to bypass some of the potential resistance mechanisms that Hawaii CRBs allegedly have. Fortunately, we didn't see those resistances, so we were actually able to inoculate our CRB fairly effectively right from the get-go. So it's always hardest the first time. This was our first time ever bringing a pathogen like this back into Hawaii. So, we were probably over-prepared, but that's good. And now we sort of know what we need to do the next time we go out for the next collection trip or have collaborators send us some. And we're anticipating either this week or next to potentially get some more specimens from American Samoa, so a territory of the US, and they can freely send us specimens with their virus as well. And basically the main goal is get that virus established in the laboratory and then do some background genetic work to see if there's any differences in the strains that we brought back from different locations and whether they have any different biological properties. Is one a better pathogen than the other? Is one, more infective? Not unlike what we dealt with COVID and all the variants. We want to find the best variant for CRB, not only for what we have in Hawaii, but this would be a resource for other locations in the Pacific as well.
Fantastic. So how do we make sure that this virus, once we identify what kills off our CRB, the kind of CRB we have here, how do we make sure it doesn't kill off good bugs or native species?
Yeah, that's a great question, and that's what we're doing exactly right now. So you heard that me say that moved around all throughout the Pacific. A lot of atolls and small islands don't necessarily have a lot of insect biota that they have to be worried about in terms of beneficials. So a lot of times they would just bring in the virus, release it right away, immediately. We have a lot more beneficial insects, plus we have some native insects that we don't want this to have a negative impact on. We don't want this to be the next mongoose or the next cane toad or anything along those lines. We want to make sure if we bring in a virus, it's going to impact CRB and CRB only and not have any negative impacts on, our native, there's a stag beetle over on Kauai, which is probably in fairly low numbers. We don't want this to be, the final thing that wipes that population out as well. We want to make sure this doesn't impact beneficial beetles, ladybugs, or things like bees or some of the other insects. Dung beetles are another one. Even though they're introduced, the ranchers and livestock people really like their dung beetles to control all the manure in their fields. So we want to make sure this is only going to negatively impact CRB and not any of the beneficials. And so that's the work we're currently doing right now, or have just started.
Yeah, I know that the biocontrol for the wasp that was infecting the willy willy trees has been really successful and doesn't seem to have, an impact on other ones. Is that normal for these viruses to be very narrow in which species they target?
Yeah, and that's where we need to know a little bit more about the genetics, because as you get more variation from the virus we're working with, there is the potential that it could start infecting other closely related insects. But in general, viruses tend to be fairly specific to a narrow host range, and we're hoping that's the case with coconut rhinoceros. This virus infecting coconut rhinoceros beetle. That is our hope, but we're the first people to try this host range testing, so that's why we really are going in a little blind on this, but we assume this is going to be reasonably specific to CRB. Fingers crossed.
Thank you. My last question on this is, what is the timeline, or what is the hoped for timeline?
That's always the most important question. I get asked that a lot. We hope to wrap up our host range testing, maybe by this time next year. Maybe a little bit more time is needed. It just sort of depends on the list of insects that people are going to ask us to test. It's not entirely up to us. Other people might say, oh, you should try this insect, that this is an important one you should try. The other big variable on the timeline, and why I don't like to say exactly what that is currently we're only allowed to work on the larval stages of coconut rhinoceros beetle. We're not allowed to work on adults. And that's going to be the same with all the other hosts that we need to test. And so, we're working on a few different avenues. One is requesting a permit change that will allow us to work on adults. We're not sure if that'll come through. If that doesn't come through, we're going to have to find additional facilities where we can do this host range testing. You mentioned the willy willy wasp. There's a big size difference, even though that parasitoid is pretty small. The virus is way smaller than that, and we don't want that accidentally escaping into the environment. So that's why having better containment generally is a requirement for working with pathogens as biocontrol agents. And so my hope is that by the end of 2027, we'll be applying for permits to release if all the data looks okay. That's my guess. So maybe a little under 2 years.
Okay, and so far has the viruses that were brought in, have they been killing the larvae?
Yes, very well.
Okay, fantastic.
Much better than anticipated. Yeah, quite there. It's very effective.
Fantastic. Thank you.